Today, we're reasoning things out, validly, of course, as we learn valid reasoning in propositional logic. We are now ready to analyze correct reasoning. Now, reasoning is understood as a set of propositions called premises or hypotheses, and another one which is called conclusion or thesis. The idea is to logically imply the conclusion from the premises. We previously analyzed reasoning with a single premise. For instance, if we have formula P and another formula Q, we say that the reasoning inferring Q from P is correct, even only if P logically implies Q. But what can we say when we have two premises, P and R, for instance? When can we say that Q is correctly inferred from P and R? Well, a moment of reflection should let you know that in order to assure this, we only need to assure that P and R logically imply Q. This is precisely the definition that we will use for valid reasoning. We will say that our reasoning is valid if the conjunction of all the premises logically implies the conclusion. We denote reasoning with premises P1, P2, until we get to P sub n and conclusion Q, and we establish all of the premises and its conclusion. Now we say that a reasoning is valid if the conjunction of all of these premises logically implies Q. Now it is time to apply all of the rules of inference in order to assure or confirm if a given reasoning is valid. Here we have a set of premises, P, Q, and R. From this set of premises, we can logically conclude that Juan must have studied at the university. In symbolic form, we have that premises are P, P then Q, and Q then R, and we have to conclude R. Now, our first step is that we have premise P. The second one is also a premise, P then Q. Now, from the first one and the second, by using modus ponens, we can logically conclude Q. Remember that modus ponens establishes that if we have P and P then Q, we can logically conclude Q. Now, that becomes our third argument. Our fourth argument is our premise, Q then R. But 3, together with 4, they represent modus ponens. The argument is valid as each step includes a formula that is either a premise or logically implied by previous formulas, in our cases, by rules of inference. Even though the method of derivation is a bit harder than using truth tables, and it definitely requires more cleverness, of course, this is the way to go, due to the fact that this method of reasoning is way shorter and clearer than using truth tables. In summary, we can say that the method of derivation for arriving to a valid reasoning can be seen as a succession of formulas where each of those formulas is either a premise or a tautology derived from the premises, and the final formula has to be the conclusion. Let us consider the following additional deductions. We will consider the following premises. The first one, R or S. Second, not P. Third, Q or not R. And fourth, Q then P. And we have to conclude S. Now, from the second premise and the fourth premise, by using modus tollens, we can arrive to the conclusion of not Q. Now, this not Q, together with the third premise, by using disjunctive syllogism, we arrive to the conclusion of not R. And again, by using disjunctive syllogism with not R together with the first premise, we get to the conclusion, which is S. And that was the key to valid reasoning, where every step checks out and every argument stands tall. I'll see you in the next lesson on logical equivalence.